Aadyot Bhatnagar, Senior Research Engineer at Salesforce. Welcome to the Data Exchange Podcast.
Thank you for having me.
So you are the co-creator of a new open source project called Merlion, which is the subject of our episode in time series in general, not just Merlion. But okay, so Merlion is a machine learning framework for time series intelligence. So first of all, why did you build Merlion? Aren't there enough time series libraries out there?
Yeah, so broadly, our desire to develop Merlion was started from this application performance management platform within Salesforce, where essentially they wanted to use time series anomaly detection in order to detect potential incidents before they actually caused customer downtime. The reason we chose to develop a new framework for time series anomaly detection, and then later we would realize that forecasting was a major need as well, was because we found that the existing solutions, there were a lot of different models kind of disjointed between different libraries, and we kind of wanted a unified interface for all of these different models, so we could easily compare them against each other and seamlessly deploy them in our production settings.
So for people who have never built a time series library, so what are some of the basic components of a time series library? Set aside the models, but what are some of the basic scaffolding that you need?
Yeah, so all of these components are kind of separated into different modules within Merlion, but the major components are first a layer to do data loading, to actually have a good data structure for the time series, which can, some of the challenges here are that with multivariate time series in particular, you can have uneven sampling of the individual variables,
or even time alignment, right? So date time alignment, right? So.
Yeah, and you can have all of these issues of misalignment, and so that's one thing we need to account for in this data structure.
So this is Aadyot, this is already presupposes that the person did some data prep, did the best they could, aligned the data the best they could, but there's still some kind of missing data, for example, right? So.
So yeah, the next layer after you've just loaded your data, which may potentially have all of these missing values, there is a transformation and preprocessing layer, and some of the things this handles include resampling, as well as a number of other utility transforms that people find helpful in time series analysis. So these could be like taking a temporal difference, a moving average, just normalizing the mean and variance, and a number of others. And so this is pretty useful in actually cleaning up the data. And so after you've loaded your data, you've done your pre-processing, then you can actually pass it to the models, which all have a unified API for training, and then also for inference, separate APIs for forecasting and anomaly detection each.
So I've used a bunch of these time series libraries. I'm gonna try yours. I didn't have time before this recording to try yours, but at some level, you have to kind of as you're building this library, you have to envision who's going to use it, right? So who's your target user persona for this library?
Yeah, so I think with this library, our goal is to target both researchers as well as engineers. So on the researcher side, our goal is to implement a lot of strong baseline models for time series anomaly detection and forecasting in one place, along with a benchmarking and evaluation framework, which makes it fairly easy to used to test different models when folks are writing new papers, so they can easily compare the performance of their proposed methods to existing baselines. And then the other major use case, and this is, I guess, more immediately relevant within Salesforce, is for engineers who have some end application in mind, and we can talk about that a little bit more later. And they want the ability to kind of have a bunch of models at their fingertips, potentially try out a bunch of stuff and see what works best for their use case, and have something that is generally usable in production without too many extra steps.
So let me drill down on both of these personas. So first, the engineer. So us engineers may not know anything about time series, right?
Mhm.
So I guess Aadyot, at some level, by way of background, so I actually was formerly a quant at a hedge fund, so I did a lot of time series work for trading models and things like this. But I've seen that was years ago, right? So, but at some level, I guess for engineers, what I envision is they would do the data prep, and then some library would magically just build the model for them, like auto TS, auto ML, right? Because they're not experts, right?
Yeah.
So is this something that you guys aspire for?
Yeah, so actually some of the features we do support are first, we did a bunch of experiments on a bunch of different data sets for both of these tasks, and kind of came up with models we think are good default models. Essentially, like the hardest part about time series is that in general, no one model works well for every use case just because time series themselves are so diverse.
That's why you have to do this automatic model sweeping
Yeah.
for them, right?
Yeah, and so the first component of this is just as a starting point, we provide a couple of models which we think will at least help people get started. And then beyond that, we provide a number of models which support AutoML features. So,
so some of these libraries, Aadyot, there's so many knobs to turn that I can't imagine I guess an engineer can do like a hyperparameter tuning kind of sweep, but seasonality, this and that, right? So
yeah. So
how much help do you provide the developer and engineer?
Yeah, so some of the specific features we have automatic seasonality detection for all models that actually incorporate seasonality. We additionally provide just automated model selection, which automatically splits the time series into train and validation splits. The user gets to specify some evaluation metric, which is implemented in Merlion as an enum, and just a list of models that they want to evaluate, and the model selection will just spit out the best one based on the user specified metric.
So is it kind of like declarative in the following sense, right? So here's my series. My task is forecasting. I just say, here's my series, my task, done. So is it that level of automation?
Not yet. And I think right now we still are trying to drill down on, I guess right now the reason we're wary of being that automated is just because with certain times you may come up with some procedure which works well for a lot of time series, but then if there is a use case where this fails, which we've seen in the past, then we don't
But
want...
then they get the diagnostics in the end. Then they can decide to go more manual. Right?
Yeah, I think that's an interesting idea.
Yeah. Whoever does this, I think, can will get a lot of usage. I think because there's enough people who have to deal with time series who don't have the requisite background or expertise, right?
Yeah, I think it's a really interesting idea to like take the automation even further in this regard.
Yeah. Yeah, kind of like like I said, declarative approach, which is here's my data. My task is anomaly detection, or my task is forecasting 7 periods ahead, 7 time steps ahead. And then you do your thing, and then there's diagnostics. Then I decide, oh, this is good enough for my use case. Right. By the way, before I ask you about the researcher persona, I'm not as familiar with the APM space in terms of what is the what kind of error and what kind of error expectation do they have? Because in the hedge fund world, when I was doing this, obviously it's profit and loss is the judge, right? So in the APM world, what's the how accurate do these models have to be?
So I guess not going too specific on the numbers, but I can say that our current models in production have over 90% precision and recall. And so in addition to precision and recall, the other metric we use is the mean time to detect an incident. And I believe this is also under 10 minutes for our system.
Classic ops metric, right?
Yeah.
So in the research persona, you talked about having a component for benchmarks. So what does that mean? That means you ship with a bunch of kind of established time series models that someone can compare with.
Yeah.
But then Aadyot, here's my data, right? So, and then I'm gonna benchmark it against these suite of known models. But these known models have never seen my data. How do I tune these known models so that it's a fair comparison?
Yeah, I think this is a somewhat tricky question, just because I think in a lot of the time series use cases, you typically will train and test a single model on a single time series. And so to some extent, like the amount of hyperparameter tuning you can do without like getting into the realm of like overfitting is, I think it is a little bit sensitive. In general, our approach when we were benchmarking models in Merlion was to kind of pick a set of what we thought was reasonable default parameters for each, just a set of like reasonable default parameters for each of these models when benchmarking and trying to keep those constant across all of the different data sets. But I think this is something which could require a little more fine tuning in order to like really eke the most out of each model.
So what so you built this library, right? So initially you probably built it for a smaller team of researchers, but at some point, as you've alluded to, it's in production. So what's the difference between when you were still in research mode to when you became production? So what kind of things did you have to add in order to make it rock solid enough to deploy to production?
Yeah, I think the biggest things that we've had to think about as we've been moving towards production has been largely how to serve these models. And I think we started building the library with like kind of knowing that we would want it in production. So a number of things which are important there, like just having good serialization, making models reasonably efficient, and so on, we'd kind of programmed in from the beginning. But then some of the stuff that we're working on now is getting Merlion working with kind of more heavy machinery that folks use in production. So this would be tools like Spark, Kubernetes, that sort of thing.
Merlion, does it have its, so it, like you said, there's a suite of benchmark libraries that one can choose to use in the context of Merlion, but you folks also supply your own library. You know, the reason I ask is I've used this other library from LinkedIn, Graykite, and they have their own models. They ship with profit, at least in the beginning, just so that you can compare. But then the idea is you would use the models that they came up with. So in your case, you also have your own models that you recommend?
We have some of our own models as well, which we've developed. In some cases, we recommend them. In others, it's not. In others, I think it's not quite so clear cut. But I think our motivation with Merlion more was, at least at the beginning, less about developing novel models and more about just kind of having lots of options in one place.
Like a whole library and a platform where people can add models.
Exactly. And so now some of our focus on the research side has been in terms of adding new models and using these existing capabilities to benchmark them and see, like, and just have good data-driven analysis of, is this model actually better than the baselines we were using before?
So what about speed and performance and scale? So for example, the most popular, or at least the most known library in the space, Prophet, I think it's kind of slower because it's tends to use Bayesian-like techniques, right? So this is where the Gray Kite folks had an opening because they could deliver better accuracy at faster speeds. So what's your story around speed and scale?
Yeah, it's a good question. I think so. This is also something we're kind of working on at the moment, but we essentially have provided models which are varying ends of the spectrum in terms of efficiency. So like on the slower end, like we support wrappers for profit. But if profit ends up being too slow for some use case, then someone may wish to use kind of a more traditional time series model like Holt Winters, which essentially does this error trend seasonality components and just works much, much faster while sacrificing some performance. I think we're also planning on adding
Wait. The tagline of the library is machine learning library for time series intelligence. Now you're quoting Holt Winters, which is a classic statistical.
Yeah, so I guess the point is more that we support the whole gamut, and we also do support some deep learning methods like LSTMs. And so kind of depending on the application's requirements for speed versus performance, our goal is to give users the option to kind of pick like where on that spectrum they want to fall. So for instance, if they have lots of compute to go around, then an LSTM could work really well for their use cases in order to get really good forecasting performance. But if
it is so I have to say the deep learning models are slow, right?
Yeah.
Yeah. I mean, it's noticeably slow if you come from like if you've used in the past mainly the statistical models. Your expectation for quickness is quite different than someone who comes from the deep learning world. But generally, what's your sense of deep learning for time series? Is it, you know, how in certain other areas like text, computer vision, audio, deep learning is dominant, right? But for structured data, less clear. XGBoost, for example, is quite good. And for time series, what's your sense? Do you think it will dominate? Forget about now.
Yeah, I think so. So in my experience, I think some of the biggest roadblocks for deep learning in time series are just that a lot of these models I find are quite sensitive to hyperparameters, which often require tweaking on different time series in order to like really get the best performance. And then also, I think in some cases there is
that statement you just made, sensitivity, is it sensitive from time series to time series, or even as a time series evolves over time and might be regime switching and stuff like that, then it becomes very sensitive as well within that same time series.
So I think they're kind of two separate problems. There is some interesting research about like non-stationary time series and using deep learning models to model those. And I think that sort of work mitigates this second concern you mentioned. But I think kind of the more fundamental issue is the sensitivity from one time series to the next.
Which means in general then because also the training time is longer, then you'd have to, if you have, and it's not unusual for a lot of companies to have thousands, if not millions of time series, right? So for example, people monitoring data centers and places like that, right?
Mm-hmm. Yeah.
So what about scale? Is scale an issue in time series in the sense of, look at, for example, computer vision or text, right? So scale is super important there. What about in time series? I guess when you get to multivariate time series. So where the scale pop up in time series?
So I think like I think the biggest issue we've seen in terms of scale is just the sheer quantity of time series, which I think you yourself alluded to earlier.
Right.
Just the fact that, like, let's say, for instance, we're talking about application performance management, then you're getting just from each individual compute resource, you're getting like CPU memory usage, number of requests, and so on in real time. And you have potentially tens of thousands, if not even millions, of these time series, which you want to analyze.
And this is an old problem. I can guess that if I dig around, I wrote a post maybe over 10 years ago about Twitter having to deal with millions of time series.
Mm-hmm. Yeah. And I think like in general, if that sort of scale is the scale that is being dealt with, I think models that are capable of running on CPUs are just a lot more feasible because frankly, CPUs are just a lot cheaper, especially when you're scaling in that way.
So do you ever need a distributed computing framework like Ray, for example? I don't know if you're familiar with Ray. Full disclosure, I'm an advisor to Anyscale, the company behind Ray.
Gotcha. We've been using Spark for distributed computing.
Okay.
For
this. That's worked for me too. I'm an advisor to Databricks. So going back to so in the time series world, what is the, how in computer vision you have ImageNet, in NLP you have all sorts of benchmarks, right? So in time series, are there known places where people can test out ideas?
So I think there are a few kind of common data sets that people like to use for anomaly detection. There are there's a few, I would say, like there's a number of data sets which we also like support in Merlion. But these would be things like data from the Mars rover, rovers. There's something called the server machine data set, and a number of others, which there's a large archive recently released by UC Irvine. For forecasting, I think kind of the standard ones people go for are like the M4 and M5 competitions. But at the same time, I think it's tricky to kind of base your entire evaluation on just these open source data sets because they don't always mirror
your own business. Your
about.
Own business time series might be quite volatile or very, very, very sensitive to external events, for example, right?
Yeah, and I think for anomaly detection in particular, is honestly just a really major challenge. I think there's been some interesting research about like the open source data sets, which argues that like the label quality in these open source data sets is often questionable. And it proposes a new method of evaluating these data sets, which I think some people agree with, some people don't. But then if you're actually collecting data internally, actually getting labels like a ground truth anomaly labels on all of these potentially thousands of time series that you're trying to collect into a data set is often just a really challenging task because
Yeah, and it's not something that you can offload to a data annotation provider because it requires some domain expertise, right?
it requires a lot of domain expertise.
Yeah, and also in anomaly detection, there might be instances where you may not have enough anomalies. Like think about predictive maintenance on equipment that rarely fails, right? So what do you do then, right?
Yeah, I think I think one of the approaches we found worked well, at least with this application performance management team, because incidents thankfully are relatively rare. But
in that space, they measure 99.9999.
yeah, the number of nines of availability. Yeah. And so incidents are quite rare in that space. And so I think the general approach has been kind of this human in the loop approach, working directly with like the site reliability engineers to get feedback on like if we detect essentially like if our model detects an incident, they're alerted about this, and obviously they need to trust in the model, otherwise they may just, if the model is giving too many false positives, they may just
right, they tune it out, right?
Yeah, so there's that aspect. And then
so the idea for a lot of these models is to give a human expert superpowers so that they can monitor a lot of time series, right?
Yeah, exactly. And yeah, like if there is an incident that is actually happening and some traditional system picks it up based on like thresholds or something and our model misses it, then we know that the model needs further tweaking, perhaps.
So is this an area, Aadyot, where that you've seen or you've heard people try out synthetic data?
It's something we're exploring at the moment, but still in the infancy, I would say.
Right. So have you heard of people using synthetic data in place of label data? And I can't imagine trusting synthetic data enough so that you would deploy without any label data, right? Maybe as an augmenter, you can augment your label data or use it for your QA testing, right? So
yeah, that's been an approach. I think we're still in the early stages of seeing like whether it's worth actually going for that approach.
So going back to deep learning, in other areas like NLP, you've got, and computer vision, the trend is, you have these foundation models or pre-trained models. In the case of NLP, embeddings, right? So even in computer vision, you have embeddings. And when we've done surveys targeted at NLP users, one of the things they seem to be clamoring for are tools for tuning models. So in other words, take a pre-trained model, trained on general data, Wikipedia or whatever, works great, but it doesn't work accurate enough for you to deploy in your specific NLP use case. So you have to tune it with your own label data. And so what they're looking for is a tool that allows them to do this tuning as effortlessly as possible, where a lot of the tasks pertaining to tuning is around labeling the right data and then having some sort of auto ML tool so that they can iterate, right? So in time series, do you think we'll get to a point where there are going to be some of these pre-trained models that can be tweaked?
I hope so, because I think that would, I hope so purely because I think the biggest hurdle for deploying time series models at the same scale as like NLP and vision models is just the fact that you need so much attention paid to each individual time series. Whereas if it's possible to kind of start from some foundation model, then I think batching, basically batching more requests over a GPU becomes a lot more feasible. I've seen some interesting papers like towards this end, including like one or two from our own group. But I think right now the technology isn't quite there. But it's an exciting area, and I hope that it sees advancements, because I think that would be a major breakthrough.
Yeah, and I think it might bring us closer to what I alluded to earlier, which I think might be the reason why we don't have it yet, this whole declarative model, right? Because basically you really have so many developers and engineers and even data scientists. Not every data scientist works with time series, right? So time series actually is a quite specific set of tools that many data scientists are not using on a day-to-day basis, right? So what we need are a set of tools where basically, like I said, declarative in nature, right? So basically, here's my data. I've spent so much time aligning, like the whole adage that 90% of the work is on data prep. I did the data prep. Now I need a tool that can build me the model based on the task description that I provide, right? So give me a timeline, Aadyot, for how long before we see this day. If I put you on the spot and make you predict, how long before we see something like this?
Before we see something like that. That's a hard question.
The problem, the thing is, you can, like I said, you do the declarative thing, then you provide them diagnostics. If it's good enough, then they're done. If it's not good enough, then they call in their data science time series expert. Hey, we need you to manually build the model, right?
Yeah.
So maybe 40, 60% of the models can be built this way.
Yeah, I think that, I guess, yeah, the biggest, I think like a major interesting area for, at least in my view, is is perhaps like refining some of the model selection itself. So I know there is I believe like the state-of-the-art results for forecasting on a major open source data set, either M4 or M5, is done by a deep learning model. But this model essentially works by doing like a massive hyperparameter search, which, takes a very long time to actually complete. And so I think like a major roadblock, and essentially if this is a research problem that,
but you can remove the deep. So let's say let's say this AutoML tool just does statistical models, right?
Yeah, so let me get to the point here. Is I think like if you have to search the entire parameters space kind of naively, then especially if you're like selecting between different models, then it's probably challenging to make this scalable, even with like some of these statistical models, because you also want good performance. I think if there, like a major interesting area would be developing tools that help you kind of hone in quickly on the right part of the search space, even when selecting between like heterogeneous model families. I think that would be quite an interesting development. Like it's specifically the selection between heterogeneous model families, so you can like quickly restrict your search space.
Yeah, so maybe it's declarative with one parameter, right? So, or here's declarative in the following sense: here's my data, this is the task, and here's the family of models I want you to search. True, right? So, but then even that, the engineers would go, well, I don't know. So what do I put in that third?
Yeah, and so I think
what family of
yeah.
models should I be searching in, right? So
And so I think like kind of that's I think a potentially very interesting question is like how would you more automatically select that third parameter?
by the way, so there might as I'm brainstorming, there might be a way to guide the user too through a UX, right? So they say, here's my model, this is the task I want, and then there's a UX which says, you know, very roughly, here's the different families of models you might want to focus here, and then you choose that, boom, auto, right? So
Mhm.
yeah.
Yeah. Yeah.
So
Doing
anyway,
this in an automated way would be very cool.
so going back to your library, so what is the current state of the community in terms of, are the contributors and committers mostly still within Salesforce, or are you starting to see contributions from outside of Salesforce?
I think we've seen a couple of contributions from outside Salesforce, including like some pretty interesting feature requests, which haven't yet been implemented, but I think like I think one interesting contribution from someone external was about like having time series models do essentially batch training on multiple time series. Someone made a PR to this effect, and it I think like got us thinking about how we could improve some of the other models to better accommodate features like this. But probably the majority is still within Salesforce at the moment.
So what are the most interesting use cases that you've heard outside of Salesforce?
Outside of Salesforce, yeah, I guess I haven't spoken too much to folks outside of Salesforce about like, yeah, just
Other researchers are aware of this library at this point, right?
just based on the GitHub engagement, I would imagine so. I just haven't personally spoken to too many of them.
So within Salesforce, the big bucket of use cases is around APM.
So that's kind of where we started. But now we're looking at more diverse sets of use cases. So just a very high level of some of the problems we're looking at now around time series forecasting include forecasting the sales of consumer goods for major retailers, forecasting the carbon emissions from various assets within a company. Let's see, there's
This is the amazing thing about this is actually the amazing thing about time series, and also what makes it an evergreen topic is that there's just so many time series, right?
The applications are just so diverse. Yeah.
Yeah. So what's the challenge with multivariate time series? Are there specific technical challenges that come into play when you're dealing with multivariate time series?
Yeah. So one, which I think we were talking about earlier, is just this issue of like time series alignment and like missing data, and in particular, like the fact that different univariates in the multivariate can be missing data at different points. And so, linear interpolation.
That is the most annoying thing. Yeah.
Yeah, and linear interpolation doesn't always cut it. In terms of just the modeling, so I think one of the model we found best was essentially we developed essentially a forecaster based on gradient boosted trees, essentially like recasting the like learning problem for XGBoost into based conditioned on like this vector of history predict like this vector in the future, which we found works reasonably well. But then if you want to forecast longer than the horizon you trained the model for, that can get dicey, just because there isn't a clear, with these kind of fixed input, fixed output, it's kind of hard to forecast for a longer time horizon into the future than what you were trained on. And beyond that, I think just the biggest issue is compute kind of just like if you're dealing with a large time series, say like 50 or even like more variables, then you're suddenly much more limited in terms of what kind of models make sense for either anomaly detection or forecasting, just because now you have just so much more data to deal with.
So what's on the near-term roadmap, 6 to 12 months?
So I guess, yeah, broadly, I'll split it into two kinds of features. One is more around like production stuff, and then the other is around like, I think, new capabilities. So in terms of production, recently I released a beta version of an API which allows Merlion to interact with PySpark. And so expect further development on this, and kind of ideally in the near future, just kind of an easy way for new users to spin up a Kubernetes cluster and run a PySpark job to like train on many time series in parallel. So that's
I just actually looked at some numbers. There's a lot of people who use PySpark, a lot. Yeah. And they will be happy to hear this. So.
Yeah, and yeah, that was we were choosing between production technologies within Salesforce, and I think, yeah, we went with PySpark partly because it has a large user community.
Yeah. And so then, the other bucket of things for the roadmap.
Yeah, so one aspect of that is to add, I think, more state-of-the-art type models. So this includes some of the novel deep learning methods, both from within Salesforce and from other recent research papers. And this is for both anomaly detection and forecasting. And then along with that, kind of reworking this part of Merlion to work nicer with GPUs. Another major feature that we're interested in is forecasting with exogenous regressors. So essentially, let's take the use case of sales, for instance. Let's say that our goal is to forecast the sales for some store. And what we're interested in is deciding whether or not we put a promotion, and seeing like what effect that promotion would have. And the key thing about this promotion that makes it different from like standard multivariate time series is that we actually know what the promotion is going to be ahead of time because we control it. And so essentially, if we can model this promotion, model the effect of the promotion on the sales as something that we ourselves control, that could be quite useful to generate insights.
Oh, so that right now is harder to do.
It's harder to do, and I think it's also kind of a question of getting the right API design, in place. And while some of the models we have wrappers for do support it, for instance, Prophet and Sarima do support this feature, it's not something we've exposed at the moment, but once we do expose it, then I think that also opens the door for us to develop more models which actually, like new models which actually do use this feature effectively.
So right now, for someone to install Merlion, what do they need? Just Python pip install?
Yeah.
It will install everything that is needed.
Yeah, the only additional thing they need to do is make sure they have Java installed on their system.
Java. Oh, for PySpark.
For PySpark, and actually also for the random cut forest algorithm, which is a popular anomaly detection algorithm, which works quite well. And there is a Python version, but it's quite slow. And so we just create a wrapper to the jar from Amazon instead.
And with that, thank you, Aadyot. And I await this declarative interface for time series. hopefully in the next 2 years. Thank you.
Yeah, thanks so much, Ben.